What if you could hand an a goal, walk away, and come back to find it actually done, the research pulled, the report written, the data cleaned? That's an autonomous agent. And by the end of this video, you'll have built one from scratch. In this tutorial, we'll build an autonomous AI agent, a program that takes a goal, decides what to do, uses real tools to do it, looks at the results, and keeps going until the job is finished. It's the pattern behind every serious AI automation, and it's simpler than it looks. We'll build it with plain Python and one API. Here's what we're building. At the center is an agent loop, where the model looks at the situation and decides the next action. We give it real tools. It can call things like web search, reading and writing files, or running a command. After each action, an observe step feeds the result back to the model so it can decide what to do next. We wrap the whole thing in guardrails so it stops safely, and we put it on a schedule so it runs on its own. This is the entire idea. You give the agent a goal. The model plans it, decides the single next action. It acts by calling one of the tools you gave it. It observes the result of that action, and then it loops, feeding what it learned back in and deciding the next step. It repeats this think, act, observe cycle until the goal is met. Everything else in this video is just the details of making each of these arrows real. You'll need a few things: Python 3.10 or newer, and an API key for a language model. Crucially, use a model that supports tool calling, sometimes called function calling. That's what lets the model ask to run your tools in a structured way. You'll want a few simple tool functions to start with. And because an autonomous agent takes real actions, you'll want a sandbox or clear limits around anything risky. We'll come back to that. Step 1. Install. All we need is the client for a tool calling model here, the OpenAI package. That's it. The agent itself is just a loop you write, so there's almost nothing to install. The intelligence lives in the model. The structure lives in your code. Step 2. Give the agent tools. A tool is just a normal Python function here. One to search the web, one to read a file, one to write a file. You collect them in a dictionary so the agent can look them up by name. This is the agent's hands. The golden rule: keep each tool small, predictable, and safe, because the model will call them in ways you didn't plan for. Start with read-only tools and add powerful ones carefully. Step 3. The heart of it. One step of the loop. We send the conversation and the list of available tools to the model. If the model responds by asking to call a tool, we run that tool with the arguments it chose and append the result back into the conversation as an observation. Then we return not done yet. If instead the model returns a normal answer with no tool call, that means it thinks the goal is met, and we're done. That single function is the whole agent. Step 4. Run it to completion. We seed the conversation with a system prompt describing the agent and the user's goal. Then we call our step function over and over. The moment step reports the model is finished, we return its answer. This is also where we place our most important guardrail: a maximum number of steps. Without it, a confused agent can loop forever and burn through your API budget. The limit guarantees the loop always ends. Step 5, and please do not skip this one. An autonomous agent takes real actions, so you need guardrails. Keep a set of tools that are safe to run automatically, usually the read-only ones. For anything else, writing files, running commands, spending money, require explicit human approval before it runs, or restrict it to a sandbox. The agent is only as safe as the tools you let it call unattended. Think of this as the seatbelt, boring until the day it saves you. Step 6. Memory. On its own, the loop forgets everything once it ends. To make the agent improve across runs, give it a scratchpad, a simple file it reads at the start and updates as it works. Now it remembers what it tried, what worked, and where it left off. For bigger jobs, you can graduate to a database or a vector store, but a plain text file gets you surprisingly far and is trivial to inspect. Step 7. Wrap it in a single entry point. A tiny main file takes the goal from the command line and runs the agent. Now your agent is one command, Python main.py, and the goal in quotes. That simple interface is exactly what we need for the final step, because anything you can run with one command, you can automate. Step 8, the payoff: put it on a schedule. One cron line runs your agent every morning with a standing goal, so it does its recurring work while you sleep and leaves you the results. On a server, use a systemd timer so it logs cleanly and restarts reliably. This is the moment your script becomes a genuinely autonomous worker goal in, work done, on its own every day. Let's recap. An agent is a loop. The model plans, acts by calling a tool, observes the result, and repeats until done. Tools are just small, safe functions the agent's hands. A step limit guarantees the loop always stops. Guardrails gate anything risky behind human approval, or a sandbox. A scratchpad file gives it memory across runs, and a scheduler gives it autonomy. That's a real autonomous agent, in about 100 lines, and now you understand every part of it. That's a complete autonomous agent, start to finish. The full code is linked in the description, so you can point it at your own recurring work today. Just remember the guardrails. If this helped, subscribe. There's a new AI build every week. Thanks for watching, and I'll see you in the next one.